Good day and welcome to a new PentaBAR. We are live now to a very nice subject and dear of mine, Go versus Rust. And in today's text talk, we'll have our one of our recurrent speakers from Pentalog, Mexico, who will dive into the present state of Go and Rust programming languages by making an objective and technical comparison to that. We'll find out how Rust and Go can be used and what is the future like for the two apparently similar technologies emerged from tech communities. We'll break some myths, we'll see programming styles and versus developer experience, and we'll look in performance for these emerging technologies. And for that, we have a special guest, which is Victor Manuel Diaz Yanez, who is a front-end engineer at Pentalog, Mexico, and has over 5 years of experience in creating digital products. He is currently working in Mexico for Pentalog, as I've already said, and is familiar with a wide range of technologies such as Amazon Web Services, iOS, and React Native. And saying that, I will invite Victor to join us. Victor, welcome. Can you hear us?
Yes. Hello, Mihai.
How are you?
I'm good. Very good. Thank you. How are you?
Fine, fine, fine. So I cannot wait to hear what you have at our disposal today and get a bit more into our subjects. I know there are some controversies over the two programming languages, but just to set the stage, tell us what they are used for and what kind of contexts.
Yeah. Well, we're going to talk about these amazing languages that I like a lot. These are relatively new for a programming language age. They are very young. We will see that one of them is maturing faster than the other. We're going to see why. The technologies that are emerging from these communities, the kind of use cases that you will need for these programming languages, in which cases you will find a better choice with Go, and in which cases you will find a better choice with Rust. But you're right in something, that the comparisons they make between these two languages is unfair. Because these languages have different purposes. So we're going to see the details of that.
So I'll give you the floor and get a bit more in how do they work. I know you have a presentation prepared for that, isn't it?
Yes, yes. Let me share my screen. Okay.
And until you do that, please feel free to ask any questions that might be interesting for you. I'll try to moderate the questions. It's better to have them in the Q&A sections because that's why we can keep an order, keeping them organized than in the chat. So do address to the Q&A and we'll take them in order, and I'll try to stop Victor as we advance the presentation. And if you stay until the end, you can get, be subscribed to all other tech talks that we have in the PentaBARs, and we'll share some other info at the end with you. Victor?
Yes. Okay. So Go versus Rust. I'm going to talk about well, let me just introduce myself. I'm Victor. I'm working in Pentalog, Mexico. Right now, I mostly specialize in myself in front-end applications, but I've worked in the overall process of building digital products. In recent years, especially, We've seen a lot of discussions when starting, especially when starting new projects, on which technologies to use or which programming languages to use to build these new projects. And in recent years, Go and Rust have been like the hot topic in that question of which language to build my new product. And it's always kind of a hot debate because sometimes it's hard to reach a conclusion without diving deeper into the inner workings of each language. We're going to see a bit introduction of both languages, a bit of history. We're also going to talk about an overview of the features of each language. And we're starting to dive into the developer experience and working with these languages. In this part, we're going to see the programming styling that these languages follow, the principal designs that are behind each of these languages, the toolchain that these languages offer for developers for building applications, and kind of speed dash performance. I don't like to say just performance because when measuring the speed of a language, you have to consider both development speed as well as how fast does the program run. And just to conclude our presentation, we're going to see the effect that these languages have had in the industry, especially in recent years with emerging technologies that have rise from these languages.
Mm-hmm.
Okay, so to introduce a little bit of these languages, these are the official mascots of these languages. On the left side, we have the Go Gopher. That's how this is called. It doesn't have a name, they just call it the Go Gopher. And on the right side, we have the equivalent of Rust. It's crab. I think it's Ferris the crab, sorry. It's Ferris the crab. So these are the mascots of these languages. In the slides, you will see on a corner, the mascot. It means that we are talking about this language in particular for each slide.
Mm-hmm.
Okay, so let's talk about Go. Go was born on 2009. It was born at Google's headquarters. They started to build this programming language, and as they state in their documentation, to get the most out of multi-core and network machines. This is the main thing about Go. So let's just keep in mind this sentence. Go, as well as Rust, is a compile language. It means that it follows a process of converting the language into machine code. On the programming language world, we all know that compile languages are the fastest languages out there because they kind of, how do you say it, use the most bare metal of a computer. That's in contrast with JavaScript and Python, which are interpreted languages. They kind of run on top of a lot of layers that interpret the instructions of these languages. So that's one of the main difference of these languages. These are compiled languages. And Golang was designed for memory safety and concurrent programming. That's one of the main ideas behind Golang, because they needed, well, Google needed a perfect language for their cloud services. So handling safety of memory and handling concurrent programming allowed them to have a better architecture and implementation of their distributed systems that they use on the cloud. So that's Golang. Golang was developed by Google. They open source the language, but it's still considered the language as being owned by Google. So that's a little bit of history for Golang. For Rust, it's relatively the same age. It came out 1 year later. In the case of Rust, this was built at Mozilla. Mozilla is the company that is behind Firefox. Rust is also a compiled language. Now the thing about Rust and what they say that it's important to consider about Rust is that they have memory and thread safety. So this enables developers to eliminate a lot of bug classes at compile time. We're going to see a little bit of more details about that, but it's considered safer. Rust might be considered safer because the compile process is more, let's say, more specialized in this regard. And Rust is also designed for memory safety and concurrent programming. So that's also important to mention. So as you can see, they kind of have the same design principle because they consider concurrent programming and memory safety into mind. So let's just keep that in mind. They basically follow the same design principle. They both tried to solve kind of the same problems, but their approach is kind of different. So most of you should be already familiar with a lot of technologies that are built both with Go and with Rust. In Go, you might be familiar with Docker, Kubernetes, Heroku. These kind of technologies emerged years after Go was published. Kubernetes in particular was developed as well at Google's. It was later open sourced. But this kind of gives you an idea that Go, as they stated in their public documentation, that their intention is more to be focused on network machines. And this has a lot of impact in the cloud industry, especially in the DevOps space of the industry. Docker, Kubernetes, and Heroku are particularly for containerization, deployment of containers, and orchestration of these systems. So it's interesting that from the very beginning, Go was already kind of focused in this part of the IT world. We also have the Lightning Network. It's a layer built on top of Bitcoin. It's also built with Go. Thanks to the concurrency that Go offers, Lightning Network, it's a very cool implementation that solves a lot of problem with Bitcoin. That's a different topic, but it's important to mention that it's implemented in Go. As we mentioned, Google uses Go in a lot of their production systems, and SoundCloud as well. This is just some of the examples. There are a lot of examples of Golang being used in production. For the Rust case is kind of different. It has had kind of an impact as well in the industry, just in a slightly different way. We have Mozilla, as I mentioned. Rust was created by team members at Mozilla because they were trying to build a more powerful engine for their browser, for Firefox. So this is already built in Rust. It's an engine that powers both Firefox and I think the Gecko browser, if you're familiar with it. Microsoft is also embracing Rust in a very aggressive way. They are rewriting a lot of critical components for the Windows operating system. They are rewriting them in Rust. We're going to see in a few minutes why Microsoft is choosing Rust for their critical components. We also have NPM. For those JavaScripts or Node developers that might be familiar with NPM, is the package manager for Node projects. They rewrote this tool in Rust to be able to handle exponential growth that they were having with users. A lot of users are using NPM right now, and they were hitting some cap limits. So Rust allowed them to have more scalability and flexibility over this constant growth of users. We also have 1Password. If you're not familiar with 1Password, it's just a password manager. Rust is also popular with cryptographic projects, projects that use a lot of cryptography, a lot of security in encoding critical information. So 1Password, most of their backend services are written in Rust. And we also have Sentry. It's an alert system that a lot of developers, I'm sure, are familiar with. They also have a lot of services written in Rust. Okay, so this is kind of an overview of how these languages are being currently used in the industry. Of course, it's not an exhaustive list, but it kind of gives you an idea of more or less the different intentions for these languages.
Mm.
Okay, so let's go. Okay, here is a simple graph. This is from GitHub. It shows you the percentage growth of pull requests on GitHub for these languages. The blue line is Golang, and the other kind of brown line is Rust. As you can see, both languages have had a steady growth on GitHub, but Golang has had an exponential growth. Every year, it's increasing the growth percentage of Go projects in GitHub. And this is interesting because it means that the adoption of these languages is greater than Rust. So more users every year are jumping in Go and are developing in Go than with Rust. So this is an interesting metric. On the contrary, if this is a survey by Stack Overflow, Rust is coming for the last 4 years as the most loved language for developers. So it's kind of interesting that we have these two metrics, right? We have Golang, which is increasing in adoption by developers, but we have a Stack Overflow survey that says that the most loved language is Rust. So developers are feeling, let's say, more comfortable and more confident with using Rust than most of the other languages. So these are the basic metrics that we currently have over the growth and usage of these languages. But let's keep in mind that the way they are growing is different. Golang is facing an exponential growth with mass adoption, and Rust is having slower growth, but there are indications that developers are preferring the confidence that Rust is providing to them when developing programs. Okay, so what do these languages look or what they are trying to fix in the current programming world? As we mentioned, one of the main ideas behind these two languages is memory safety and concurrent programming. And if you're familiar with compile languages and you have to build a project that takes the most out of a computer, you will usually choose C or C++. It's the The oldest, not the oldest, but this is one of the, from the modern programming language, is the most widely used when dealing with high performance applications. The thing with C and C++ is that memory management is very hard and is very dangerous. Most of the issues with desktop applications that are written in C and C++ is because of the development mistakes, mistakes from developers when dealing with memory and with memory management. Because in C and C++, you have to say, I have this variable and its size would be 64 bytes. And if you try to fit that variable with more bytes than what you defined it was capable of, your application will break. And it will break once it was running, so once it was in production. So this resulted in high costs for maintenance and scalability. A lot of bugs, you have to fix a lot of bugs that were very hard to spot. You would need hours of code review from expert developers to spot critical bugs, or you will have to use a lot of static analysis tools in order to find these errors. So C and C++ gives you a lot of space to make very easy mistakes, and mistakes that are very hard to spot until it's running in production. C and C++ also has arcane tooling. It's very hard to deal with the compilation process. It's very hard to deal with dependencies using third-party libraries. It's really a headache working with C, C++ on this regard. I'm sure there are a lot of tools that improve the experience, but C and C++ doesn't offer things out of the box that will make easy for you to have a better experience when developing applications. So we know this basic mistake, right? You just program, you allocate all the memory that you want. Nobody complains. Your computer doesn't complain. The compiler doesn't complain. But when your application is running, it just crashes. And it sometimes might crash really bad, like blue screen of death bad. So yeah, if developers are not careful with C and C++, they could really mess up really bad. So the intention of Go and Rust is to have an alternative to C and C++, because, well, due to these problems, developers need to be more productive, and this kind of error-prone kind of programming styling, it's really messy to work with, especially when writing big software with a huge team. It really becomes very hard to coordinate everything. Okay. So before we dive into actually comparing these languages, I would like to break some myths when doing comparisons. As I mentioned, languages are designed based on different principles. Just as program looks to solve for a problem, a language also looks to solve for a problem. In this case, a problem for developers when building programs. So you would have, for instance, you have Python, where it solves the problem of not having a compilation process. It solves the problem of not being restricted with typings. You can also say the same thing about JavaScript, that it helps the developer to avoid typing problems, to program a little bit faster and not worry about memory management. But these languages also have problems. So Go and Rust not only try to solve memory management, they also try to solve many problems that you can find in many languages, including dynamic languages like Python and JavaScript. So at the end of the day, choosing which language is better is based on trade-offs. You have to ask yourself which language is better for my particular use case, rather than which language is the best of the world. You will find that a particular language is better for a particular implementation or for a particular application, but sometimes you will find another language better on some other particular use cases. Okay. So Go and Rust. So now let's talk about the main features for each language. The main features, what these languages' main characteristics are, what the toolchain looks like, and what are the things that you can build with these languages. So Go is as we mentioned, is a compiled language, but it has type safety. This means that it has the compiler follows rules, so your variables have a certain type, and you don't mix different types in expressions or operations. The thing with type safety is that it allows you to not make mistakes like adding a string with an integer number. Some things, those are things that you can do with dynamic languages like Python or JavaScript. So type safety allows to find any possible mistake by the developer when misusing a variable that was not intended to be used in certain ways. Golang also has garbage collection. This is the main element for Go in memory management. As we mentioned in C and C++, memory management is done manually. You have to say this variable needs a certain amount of bytes. And with garbage collection, you don't have to do that. In fact, you don't have to worry about whether you are whether a variable is not being longer used. Garbage collection will automatically detect when a variable is not longer in use, and it will free that space. The thing with garbage collection is that it introduces a kind of latency for your programs. Since it's an iterative process of checking the references and the variables, it kind of introduces a bit of latency. It's important to mention that the garbage collector that you find in Go is very fast. It's faster than garbage collectors in Java, for example. So the latency is actually very minimum, and it's acceptable for a lot of applications, including distributed systems. So yeah, garbage collection in Golang it's kind of magical, let's say. We also have a very strong structural typing in Go. In Go, we don't have object-oriented programming per se, but we could have some patterns of object-oriented programming. We're going to see a bit in a minute. But when I say structural typing, it means a kind of object-oriented programming with structs only. We're going to see how that's achieved. Golang also allows you to have modular programming in a very easy way. The way that you package your libraries or your application, it's very modular. So this helps a lot in scalability, especially with big teams. And concurrency for Go, as we mentioned, both languages are focused on concurrency. With Go is a little bit special because the concurrency functionality for Go, it's embedded in the language specification itself. You have particular keywords for the language where you can use concurrency. And in terms of syntaxes and readability, it really is very simple and very minimalistic for Go. Golang easily is the easiest programming language where you can have multi-threading. So yeah, you could say it's a minimalistic concurrency programming style. Okay, so for Rust,
we do have a question. Actually two, but I let you choose if you park them. And one is anyone of Go or Rust a good fit for DSC and machine learning AI?
Okay.
You may choose to answer now or after you go over Rust. So how do you feel it?
Yeah. DSC, I will assume is data science. So basically, Rust and Go for machine learning and data science are in an immature phase, let's say. They have proven to be very performant for these applications, but it's very early to say which one is a better fit. And there's a reason for that. Right now, the top language for that is Python. So data scientists and artificial intelligence scientists are very used to Python, and Python will be the chosen language for a lot of years to come. Why? Because most of those algorithms rely on numeric libraries like NumPy, which they are actually implemented in C, and they are just binded to Python. So when you're building machine learning or when you're building data science in Python, you're actually using under the hood C and C++ libraries. It's kind of hard right now to migrate all those libraries to Rust and Go. There are already solutions. I've seen more activity on this with Go than with Rust. So you will probably find more examples of data science and machine learning with Go. Rust also has implementations, but they are not as mature as Go. So yeah, right now Python is the king for that, and we might have to wait a little bit of more years.
An additional question to that, and some more are coming. So can we use those libraries with Go?
Can we use those libraries with Go? That's a good question. So in theory, yeah, I wouldn't know. I actually don't know how the binding with Python works. But if there is a specific binding implementation for Python, you will probably need something similar for Go. But the thing with Go and Go is that it's kind of unsafe. to use Zero, and it can it be not very straightforward. So I would say in theory yes, but it might be very, very complicated to achieve it.
Okay. Maybe, I mean, maybe you can elaborate on the reasons to do that. I think David, said that. And another question is, what about API REST frameworks? Are there good options for Go, Rust, or are still better some options with JavaScript and Python like Express, Flask, DRF, others?
So there are good options. I mean, we don't have like the, let's say, like the main framework for Go or Rust, like in JavaScript with Express, because in JavaScript, Express is like the main framework for JavaScript backends. And with Python, you have Flask for lightweight backends, but you also have Django. In Go and Rust, we have similar libraries. We have more libraries for Go than with Rust, but we already have libraries that offer you the same out-of-the-box functionalities like in other languages. In Rust, I particularly like Actix Web, it's called. I've built backends in Rust with that. It's very similar to how Express works in JavaScript. You define your main instance for the backend that it's running in a loop. You define all your controller entries, your methods for those controller entries. And of course, you have also kind of your middlewares to process JSON responses, to process authentication, cookies, all those things. For Go, there are more options for Go. We have Gorilla out there. There's also I forgot the name.
Is not that important. Being mindful on the time, I would accelerate a bit on that. I have one more question, but I'll ask it in the end. I'll park it. Okay. And then let's go over Rust and accelerate a bit until the end.
Okay. Okay, so Rust. Rust also has type safety. It's kind of similar, just taking care that the variables that you defined have the same type. You cannot mix different types on operations. And with Rust, we don't have garbage collection for memory management. We have something called ownership system. And this is the main, let's say, the main complex thing of the Rust language is the ownership system. For new developers, it will be the same as just learning your first language. But for developers that already know programming languages, they might find a very hard time trying to get around the ownership system. This is the main feature of Rust that makes Rust slower to learn, let's say. But it's also the feature that makes Rust Rust. It's the main thing that makes Rust very secure, that makes Rust very fast when the program is running. So we're going to talk about a little bit of the ownership system in a bit. Rust has a structural typing, kind of similar with Go, but it also has generic. This is something different from Go. You can achieve a certain degree of generics with Go, but not the same level as with Rust. Some even say that the generic the generic advantages of Rust win over the C and C++ templates generic syntaxes. Rust has a stronger focus over functional programming. It's kind of weird that we are seeing languages move away from object-oriented programming. Rust is very strong for functional programming, but it also has a similar module system as Go. So it works as well with modular programming. Yes?
We have a bit of what about dependency injection in Rust and Go?
For dependency injection, it's kind of different. We're going to see in a bit the package management that we have for Go and Rust, but it's kind of the same way that dependency management works for JavaScript. I know it might sound weird because there are different programming languages, but we'll see in a bit how package management works for these languages. Rust has a lot of immutability in mind. It's kind of different from many languages because by default everything is immutable. In Rust, you have to explicitly define in your code when you want a variable to be mutable. So this is kind of different from the other languages because it's the other way around. With other languages, you would usually have all your variables mutable, and when you want immutability, you will declare a constant. So this is kind of different with Rust.
Mm-hmm.
Okay, so we've heard a little bit of the overview of the languages. We could say these languages are similar, but they are actually different.
It's like, I like this expression, same but different.
Yeah, so they are similar in the sense that they want memory safety. They want developers to be more productive. They want to offer better solutions for concurrency programming. As we mentioned, concurrency programming might become very hard in other languages, even in languages like JavaScript or Python. They also have powerful toolchains. I think I mentioned this earlier, that these languages have tools out of the box provided, like the official tools, and they are very, very powerful. It's not only the compiler, but they have a formatting tool, documenting tool, the package manager tool. We're going to see some of the tools and how they work. But the tool chains that comes with these languages are very powerful. And they both have cross-compilation among different platforms. And this is something huge because in other languages, you would usually need to compile. For instance, if you would want a program to run in a Mac, you will need to compile it in a Mac because you would have all the libraries there. And the same with Windows, you would have to compile it from Windows. And with these languages, you can compile from your Windows machine and target Mac devices, target Android devices, target iOS devices. And this is a powerful feature of these languages. You can cross-compile to different platforms without having these platforms locally. Okay, so now we saw an overview of these languages. now let's dive into the developer experience. Since these languages have different design principles, these design principles directly influence how the experience of the developer is when using these languages. One of the things, as I mentioned, one of the things that makes this experience a lot better than a lot of languages are the toolchains that come with them. We talked about dependency management. Dependency management, it's very straightforward with both languages. I will lean towards Rust in this topic because it's a bit easier to use the package manager of Rust than with Go. But in any way, Go package manager, it's a lot better than a lot of languages. They offer you out of the box, you know, you just say, I want to import this library into my program. They will handle getting that library. They will handle getting the right version. They will handle keeping the version that you installed for your project. So unless you explicitly say that you want to upgrade, they will keep the same version. This is similar to what we see with Node.js projects and the package lock JSON. Like the file says, it locks the version of your dependencies, so you don't have compatibility issues. Part of the toolchains, we also have a special linter for these languages. It's a code formatting tool. And this is very helpful because if you've worked with languages like JavaScript, you have to use third-party libraries in order for all the developers to have the same format, the same indentation space, the same nomenclature for your methods and variable names. So it's kind of hard to have a very good code formatting in large teams for different languages. Some other languages reach the point to say, let's include this in the design of this language, like Python. Python has indentation built in their syntaxes. So a Python program won't build if you have grown indentation. So Go and Rust didn't include this in the compiler, but they include a very useful tool to format your code. It not only allows you to have better readability, but it also kind of pushes the developer to write better code, better formats, and to comment, especially to comment your methods and your structures. And this complements other tool that its main purpose is to generate documentation. Both Go and Rust have the document tool that it basically self-generates documentation based on your code, your methods, and the comments of each method. So this is very useful for development experience. And we just mentioned cross compilation, so I won't go over that again. Okay. So with both these languages, there is.
Just before going forward, can Rust compile with an unused declared variable?
With an unused declared variable, no. No. We're going to see that in a bit when we dive into the code. Okay. But no, it's kind of weird because there's a similar behavior in Go with constants, but we're going to see that in a bit.
Just be mindful that we have 10 more minutes, yeah?
Okay, so I'm going to speed up a lot. Yeah. So learning the all habits. So in order to program with Go and Rust, you have to unlearn some old habits that you have with other programming languages, especially Java or C# or languages that are very strong with object-oriented programming. The thing is that these languages don't implement the class keyword. So you don't have classes, you don't have objects the same way that you have in other programming languages. You don't have inheritance. You also don't have method overloading. Method overloading is when you have the same method but with different signature. You also have a different way of error handling. You don't have the classic throw error, try catch. So it's different how you handle errors in both Go and Rust. They both handle it very similar, but they are kind of different. And the most important thing is that we don't have null values in these languages. And this is a huge improvement for safety because handling null values in languages that support null values, it's a headache. I know many of you have experienced this, maybe in JavaScript, we don't define, maybe in C and C++. Dealing with null values, it's a headache. So Go and Rust eliminate this possibility. They have another way of dealing with kind of null values, but they are not actually null values. So let's start looking into a bit of code. Here we have a basic hello world. On the left side, we have the Go equivalent, and on the right side, we have the Rust equivalent. The first thing that you may notice is that Rust doesn't have any kind of import or any kind of library introduction into the program. For Go, it's important to mention the language of Go is very small, very, very small. You can actually read the language specification in 2 days, and you can be writing useful programs in 2 or 3 days. So the language specification of Go is very small. You will spend more time learning about the standard library of Go than the actual language. Rust is another story. Rust is overly complex. But in this case, in this example, the main difference is that Go is importing libraries to use the print method, and Rust is not. The thing with Rust is that there's no such thing as importing a library. In Rust, you simply have the library available. In this case, the standard library available, and you don't have to import it. In Rust, you have the keyword use. That's how you kind of import different modules. But use is more like referencing namespaces inside your modules. All your libraries, as long as they are defined by your package manager, they are available for your program. In this case, we're just printing hello world. You will see an exclamation mark here in Rust. This is because this is a macro. A macro is similar to the macros in C and C++. They just they are like a shortcut for a piece of code. In this case, this macro is a shortcut for the standard output method of writing this into the IO stream. This is variable declaration. Both languages have infer types. You can explicitly define your typings. In this case, in this line in Go, we are multiple defining variables. In this case, it's just one library and we're specifying the type. In this case, it's an infer type. It infers the type based on the value we're providing. So we just print, and there you go. In Rust, it's similar but different. In Rust, you cannot declare multiple variables in one line. You have to use kind of a tuple destructuring. This is a tuple destructuring. Basically, I'm declaring a type of a tuple and then destructuring into 2 variables. We also have infer types. In Rust, it goes beyond because it can infer from the context. In this case, it infers, if we wouldn't have the next line, it would infer that this is an integer of 32 bits. But in the next line, we are assigning this same variable a different typing. So the compiler infers that this needs to be an integer of 64. So this is a more powerful infer typing because it analyzes the context of the method of the program, and based on the context, it infers types for other variables. And this is from the question that someone was asking. In this case, I'm declaring an F variable, and it is complaining. Here we can see a red dash. It's complaining because the F is not being used in our program. This is in the case of Go. So Go won't allow you to have unused variables, unused methods, or unused imports. If you import a library that you are not using, it will throw a compiler. But it's weird because we here have a const, and it's not, the compiler is not, let's say, it's not complaining about anything. That's because since a const doesn't change, the compiler is smart enough to say, okay, since this variable doesn't change and it's not been used, we can completely disregard it from the program. So compiling this would be the same as if you remove this line. So that's the difference. We also have, how much time do we have?
Less than 5 minutes.
Okay. We also have arrays and slices. Arrays and slices are similar in Rust and Go, but they kind of behave differently. They are similar in the sense that they they reference a range in an array. But in Go, you would use more slices because the slices are the ones that have all the method implementations to actually manipulating these lists of values. In Rust is kind of different. Slices are just a reference to a range of arrays. The way they are declared are also kind of different. In Go, you defined the number of the length of your array. And by default is initialized with the 0 value. In Go, you don't have nulls, but you have a 0 value, which is the default value of a variable that is not initialized. In Rust, you have to explicitly initialize. And in Rust, when defining an array, you have to, it's a different signature because you have to specify the type of the array and the number of elements as part of the typing signature of these elements. And if you want to declare default values, just the same as in Go, you have to explicitly say. In this case, I'm saying that I want 5 zeros for this array. Looping over arrays and slices, it's also kind of different. In Rust, you have the in keyword, which you can iterate over slices. You cannot iterate over arrays in Rust. You only can iterate over slices. In Go, you can iterate over both with the range keyword. Rust doesn't have the classic for loop that we have in C and C++. So you kind of have to declare your index outside of the loop to have a similar behavior like that. We also have flow control. Flow control, it's very interesting in both languages. In the case of Go, the if statements, you can have multiple expressions on your conditional evaluation. You can just separate your expressions by a semicolon. But you can basically have different expressions and then finally bool evaluation. In this case, for Rust's case, we don't have the same kind of if, but we do have an assignment if. And if you have programmed in Swift, it might be very similar, where you, as part of an if statement, you are assigning a variable. In this case, I'm creating the res variable. I'm evaluating here an expression. And based on that expression, I'm returning either of these values that will get assigned into res. That's why I'm ending the if with a semicolon. And this doesn't have semicolon because this will be directly assigned to these values.
Until just to make a little announcement, until Victor, you're preparing to finish, I just want to make sure that if you have questions that might be, you want them answered, please put them in, and we'll take 5 to 10 more minutes just to be sure that we respond the question if there. If not, we're preparing to end, and I'll make the announcements for next week because we have a very, very interesting speaker that will speak about growth in users, and I'll make the announcement there.
Yeah. So let's dive into one of the main features of these languages, which is concurrency. Concurrency, as we mentioned, is easier with Go because it provides particular syntax for multi-threading. You have the Go syntax to declare a function that runs concurrently. And in this case, it's just a timeout, a basic timeout of 10 seconds. And while we wait, this is called the Go routine. The Go routine runs. And if we want to achieve a similar functionality with Rust, we have to rely on libraries. In this case, we're using the standard library, the thread structure. And this is a syntax for kind of, let's say, lambdas. It's just an inline function for this thread. And this kind of implements the same 10-second timeout as in Go. As you can see, the syntax can look a little bit more complex in Rust. The truth is that for Rust, you have to rely on other libraries for multi-threading. In this case, this was an example with the standard library, but we have third-party libraries that are more easily to use for multi-threading. I'm missing one example. Okay, yeah, I'm going to move on. But just as an important mention, in Go, we have also the channels. Channels are a way to communicate with these parallel methods that are running concurrently.
And one question is there an equivalent for channels in Rust?
In Rust, we have an equivalent for channels. It's, like I mentioned, it's a bit more complicated because you have to implement a kind of messaging way. In Go, it's very straightforward because it already provides you the syntax for that. In Rust, you have to implement the actual channel. You don't have an equivalent channel from Go to Rust, but you have to implement this channel, how this channel will work, and how this channel will dispatch messages between the threads and your main thread. So you kind of go, let's say that Rust forces you to implement the channel logic in contrast than with Go.
All righty. Can we end it here? And maybe if we have questions, we may do an edition number 2 for that. Yeah, sure. I would just go to the questions if you can, and maybe not share the screen for that, but we have 2 more questions. it looks like Rust can sometimes become overly complex. Why not design it like Go? I think that's, I don't know if it's a question or a mention, but it's interesting.
Yeah, yeah, yeah. It's interesting question because I mean, if you already have a simple solution for language like Go, why go with Rust, which is overly complex? The reason why is that Rust has, let's say, more language functionalities out of the box than Go. And since it has a very, very strong compiler, you have to be explicit on a lot of implementations. Go allows you certain degree of ambiguity on your programs, and with Rust you have to be more explicit. So with Rust you have more keywords. With Rust you have more operands. With Rust you have more symbols, and this is because it requires you to be more explicit on how your program will function.
And go ahead. Another mention is Go is super fast at development speed and compile time. Isn't that a major win for companies on their cost budgets? And maybe you comment a bit on scalability also, because we had discussions.
Yeah, so it's a major win. It is a major win. As I mentioned earlier, this is a decision of trade-offs. While you might find Rust slower when starting a new project, on the long term, it will save you a lot of money. Why? Because the Rust compiler serves as a gatekeeper for developer mistakes. So it won't easily allow you to introduce a mistake that you will later find in production. With Go and especially with the interfaces typings, you have some kind of unpredictability for Go programs, and you have to be extra careful of not introducing empty references or calling methods that doesn't exist. So Rust has a stronger compiler in that sense. So it's a trade-off. You will be slower developing programs at the beginning, but as you go, you will be faster and your code will be more maintainable.
And I would say, just to close up the questions, if you want to go deeper into the subject, please mention that in the feedback you've received the feedback form, and we can address. Then you have the link to other PentaBARs that are equally interesting on several subjects. And I will end with these combined questions that we have from the two, but not before saying that next week we have Raresh Huțanu, which is the head of development for Bitpanda, a leading European neo-broker. And he will share the technical insights, stack and journey, plus organization that he established in order to get from few users to 1.5 million users in 4 years. And this it will be how to develop a fintech product explode, with an exploding user base, and that will be somehow different but very interesting from some perspectives. And the question would be, don't forget to subscribe. The question will be, are these languages going to become industry standard? And I will combine it with the second question with what else can we expect from these languages in the future?
Yeah. So it's interesting. It's hard to say if they are going to become industry standard. I don't think so, because as I mentioned, since languages is a trade-off, you will still find better use cases for other languages. What I can tell you is that the exponential growths are indicating that this will dominate the market in a few years. And one special example of that is Microsoft's decision of rewriting some critical components of their Windows operating system into Rust. And of course, the impact that Golang has had in the infrastructure, in the DevOps industry especially. So I don't think they will become the industry standard for languages, they might become industry standard for specific domains. Golang is becoming the industry standard for DevOps, and Rust might become the industry standard for critical components, especially components that you don't want to be unpredictable, like infrastructure components in nuclear plants or components critical to an operating system like Windows. They might become industry standard on their own domains. We will have to wait to see what those domains are.
Thank you very much, Victor. It was very interesting. I'm sure we can go deeper into these subjects. If you want to see more, don't forget to subscribe to the channel and go deeper into those PentaBARs. Ask for more if you want it, and stay tuned to the PentaBARs. Stay close to Pentalog, because we're doing this series from a sharing perspective. And giving knowledge, and if you want to get close to our community, just subscribe there. Bye, and thank you.
Can I answer this last question?
We have a last question, which is, like it, yeah? So it's not suited for as much. Let me just state it for everybody. So Rust is not suited as much as Go for DevOps systems programming?
Yeah, so that's an interesting question. It's not that it's not suited. It's just that Go overtook more rapidly over this industry. We have very cool solutions for Rust. If you're interested in what kind of emerging technologies we can expect in the DevOps world, you can check a project called Crostlet. It was developed by the Microsoft Azure team, and it's basically a bare metal container written in Rust to run in Kubernetes. So it's not that it's not suitable, it's just that Go is more simple in building these kind of applications.
And we have another interesting questions. I was just on my lips to mention. If you want to follow Victor, sure. I mean, where can they find you, Victor? I mean, stay close to the Pentalog, because and if you have special requests for that, do that. But if not, are you on LinkedIn or any social media out there, or other GitHub? I don't know.
Yeah, let me share my both GitHub accounts.
And you'll have them here in the chat, and stay in tune. And he might answer additional questions if you have.
Yeah, I might not be very active in GitHub, but I occasionally publish interesting things from time to time. So those are my both GitHub handles. But yeah.
Cool. Thank you a lot, Victor. Stay tuned. We have very interesting PentaBARs. Victor is a recurrent speaker, and we might do other and entering deeply, and maybe some simulation and some study casing in the same area. Just ask for it, and you'll see the tune of the community and serve it back to you if it's useful. Thank you, Victor, again.
Thank you, Mikhail.
A lovely day for those that are in Mexico, and a lovely night for those that are watching us from any other countries.
Thank you.